Hey, it's me from Minute Earth. So last week we got a bunch of comments asking us to do an ice melting race. And since we love a good race here at Minute Earth, we couldn't say no.
Oh.
So we put two identical looking ice cubes out in the sun. One on white paper and one on black paper, and we started a timer. The question was, which ice cube would melt first? And if you know anything about how color works, or if you've ever tried to get a tan, you probably know that darker colors absorb more heat than lighter colors. So we were pretty sure that the ice cube on the black paper would melt first. But in order to prove it, we had to do the experiment. And here's how it went down. We placed two plastic tubs, one filled with ice water and one filled with just water, out in the blazing hot sun. Then every 10 minutes we recorded the height of the ice cubes, and we waited. And to our surprise, they both melted at the exact same rate. Which doesn't make sense because the black surface should have been absorbing more heat and therefore melting the ice faster, right? But maybe it was the white ice reflecting more light and therefore staying colder. To get to the bottom of this, we repeated the experiment with black and white paper and two different kinds of ice. Regular ice cubes and ice made from distilled water. In both cases, the darker paper absorbed more heat and the ice on the black paper melted faster. In fact, the ice on the black paper melted so fast that in one trial it completely disappeared before the ice on the white paper even started melting. And the distilled ice cubes on the black paper also melted way faster too. Here's why. You see, substances that are good at absorbing heat, like black paper, are also good at absorbing light. And the energy from that light gets converted into heat. And when that happens in something like ice, the molecules absorb the energy and start vibrating faster. If they vibrate fast enough, they actually break their bonds with each other and switch from a solid into a liquid. But some materials, like distilled water, are better at conducting heat than others. So once the ice starts absorbing energy and vibrating, the vibrations spread quickly through the material, and the ice melts quickly too. And that's why in our experiment with distilled water ice, we saw such a huge difference between the black and white papers. Regular water ice, though, doesn't conduct heat as well, so the ice stays cold longer. And that means that the color of the ice itself didn't really matter in our first experiment because the ice was unabsorbing any significant amount of heat from the surroundings. It was the paper that was converting all that light energy into heat and then transferring that heat into the ice. And it's the same thing that happens with glaciers. Sometimes glaciers get covered in soot from wildfires or pollution, and that causes them to absorb more light and therefore melt faster. Now, at the beginning of this video, I asked you a riddle. I'm not hot, but I melt the cold. What am I? And you've probably figured it out by now. It's black paper, or more generally, dark colors. Leave your answer in a comment and subscribe for more cool science. And we'll see you next time.